the most orchestras have, of course, string players and wind players and brass players and percussionists and so forth, but most orchestras do not have a permanent pianist. So I have no pianist today except me, and I'm not much of a pianist, but I've got a few recordings of pianists that I can play who are better than almost anybody ever. Now, in a piano, the generator of the sound is the hammer hitting the string. Remember, we need a generator, we need a resonator, we need a radiator to make sound. The generator of the sound in a piano is the hammer. In older instruments that we'll talk about, there are other ways of doing that. The radiator is the soundboard, and the resonator is the soundboard, and the radiator is a combination of string and soundboard. But I want to talk a little bit about the tension that exists in a string. And to do that, I'm sorry, but one of my favorite, I like languages, and one of my favorite languages is mathematics, because as I said earlier, it's a language in which you cannot make mistakes. You can make mistakes, but it tells you. There are no misunderstandings, a better way to say that. So I want to start with Mersenn's formula again, where the frequency is 1 divided by twice the length of the string multiplied by the square root and of the tension in the string and divided by the mass of the string in kilograms divided by the length of the string. And so this formula is way back from the 17th century. And what I have done, and I'm sorry, I don't mean to make anybody nervous with this algebra, but as I said, I couldn't resist. I've solved this for the tension, because I want to calculate the tension. And it turns out to be the mass of the string divided by the length multiplied by this quantity, 2 times the length times the frequency squared. And then I can play a little bit. Now, to get the mass of the string, what I do is I take the density and I multiply it by the area, the density of steel. And so I'm going to take the string, which is middle C, this string, middle C. Middle C is basically 262 cycles per second, or hertz, if you remember that name. This one actually says it's 261.6. And since all this does is move a little air, you won't be able to hear it if I bang it. I don't think. I can hear if I hold it right. Can you hear that? And of course, if I put it on a soundboard, it makes a little bit more noise, but not much. If I do that calculation, I work all the way through that, what I get is a tension of a thing that's about 1,000 newtons. A newton is the unit in which force is measured in the system where we have kilograms and meters and so forth. And it corresponds to lifting a weight of about 100 kilos. Okay? So the tension on that string is approximately equal to a 100 kilo weight. If I go down, that's C4, the 4th octave on the piano, this note. Can you hear that at all? I don't know. Okay, if I go down, that's C4, the 4th octave, 3, 2, 1. Okay, if I go down 4 octaves, every time I go down an octave, I change the frequency, I half the frequency. That means if I half the frequency, I have to double the length. So if I double the length of the string and I go down 4 octaves, I have to have a string that's 8 times as long. The middle C key on the piano is 80 centimeters long. If I multiply that by 8, I get 640 centimeters. I get 6.4 meters long. That's a piano that reaches up most of this room, and that's not reasonable. The actual C1 string in the piano, the actual C1 string in the piano No, I want to stay on the PC for the time being. Okay. How do I do that? It doesn't. Sorry?
It takes a bit.
Oh, it takes a while. Okay. The actual C1 string on the piano is, can you make it go back on one of the screens, is only 1.4 meters long. It's not 6.4. Oh, there we go. Thank you. Not 6, well, on one. Not 6.4 meters long. And that's compensated for by increasing the mass of the string, making it just heavier, so I can make it shorter. Now, if I were to just make the same string out of steel, thicker, that would not work very well. And so, as we will see later on, the lower strings of the piano are steel wrapped with copper to make it look like a heavier system. We'll get this working, I'm sure, in a bit. Let me see where I am. Now, in a piano, remember the C4 string is about 100 kilograms of weight. The C1 string is about 70 kilograms, still a significant amount. On the piano, there are 88 keys. There are 52 white keys and 36 black keys, and 88 keys in all told. But many of the things have more than one wire. And so if you count the number of wires, there are roughly 230 wires inside a piano, each of which has a tension of between 700 and 1,000 newtons. And if you calculate all of that, the total tension of the 230 pieces of wire is 200,000 newtons, equivalent to picking up 20,000 kilos or 20 tons. That's why if you look inside a piano, you will find it's got a big metal frame, because metal can stand that kind of tension. And as we shall see, if I can get the slides back.
If you take your pointer out of your hand.
Oh, am I shining it at you? Oh, heavens, I don't need to do that. Actually, it isn't bad, and it's not powerful enough to hurt your eyes.
No, that's how you change that. With a pointer, you push the advance thing.
Doesn't do anything. You've got to, yeah. No, and I certainly don't want to point it at anybody. But, I mean, one of the things that physicists do, because we're a little crazy, if you've got a low power one of these things, you can shine it right in your eye, and that will saturate the cells that are red. And so it looks green when you do that. That's kind of fun, but not necessarily highly recommended. I wouldn't do it with a green or blue laser pointer, but I'm willing to do it with a low energy red one. Okay, now the piano is not, of course, has a long history, and what I'd like to be able to show you, which eventually I'm sure I can, is the development of the piano. And one of the first instruments was called the Dulcimer. And I have a picture of a Dulcimer in which it's actually just a bunch of strings, and it's struck with hammers that are made out of cotton. Okay, and it makes a very soft sound. But the first instrument we have with a keyboard is probably the clavichord. And I'm hoping to get a picture. I have a picture of a clavichord, but a clavichord was a very small instrument, and it had the keys parallel, the strings rather, parallel to the keyboard. And the real problem with the clavichord is, how do you strike the string? Okay, and the clavichord had the worst possible way to strike the string. Namely, in a violin, as we saw yesterday, you can bow to move the string, or you can pluck pizzicato to move the string. But the softest sound you can make is to just bang the string. And that's what a clavichord did. It had a piece of metal called a tangent, and that tangent came, when you pressed the key, the tangent came up, it pressed the string, and that made a sound. Okay? It was very soft. It couldn't even fill an ordinary salon, let alone a room of this size. And so it was nice. It made a sound. It was portable. It was easy to use, but it was not great. The next development, of course, is a pizzicato system, a system to pluck the string, and that device is called a harpsichord. And in a harpsichord, we have a plectrum, like a pick, again, in which, well, I've got something. Now maybe I could get this. This thing doesn't seem to want to shift very well. It'll be okay if it doesn't work. It's okay, I can just talk. I'd like to have the sound because that's fun. And if it works, it works. With a plectrum, you press the key, and there was a piece of wire that didn't go up and hit the key, but it had a horizontal piece of wire, and when you pressed the key, the wire went up and went boom, and pressed the key. And this is a very nice device and extremely useful for particularly for polyphonic music, which was so popular in the Renaissance. Polyphonic music, again, is music in which there are two tones or melodies going together at the same time, it was very popular, as I say, in Renaissance times. If you go to, and I think I mentioned this before, but if you go to medieval cathedrals, often in Europe, you will see that they have two organs, not one, and they play on both sides of the church and for polyphonic music. But this started to lose popularity with the increase of popular music at about the end of the 17th century, and with also with the growth of opera, which made a big difference. And so the harpsichord began to lose popularity, as I said, and the difference then became a new instrument was needed. Unlike many instruments, we know the inventor of the piano. Okay? The inventor of the piano is a man named Bartolomeo Cristofori, an Italian, and he was, well, I have his dates on the slide, which I can't show, but he lived sort of from the mid-17th to the mid-18th century in that period, and he invented the piano. And I do have here, which I can show you, I have a picture. So I get something. I have a picture of the mechanism invented by Cristofori, in which you can see the key is pressed, and that pushes a lever, which pushes this lever up, and the hammer strikes the string, and there are two dampers here, this one which comes down and stops the string from vibrating, and this one which softens the motion of the lever when it comes back down, so it can't bounce back and strike the string again. Okay? And this action about 1720 was, oh my goodness, well done, young man. Thank you. Whoops. Gone again. Oh, well. It's not up. Okay. About 1720, he invented this action, and that began the piano. Now, I also have there are 3 Cristofori pianos in existence today, and somewhere on the slides I have a picture of one of them. But they were small objects. They had 4 octaves instead of 8 octaves. Yeah, there's, no, that's that. Okay, that's my laptop. We'll see. He'll get this. He's a very clever young man. The problem is this machine isn't working right, but it's not anything we're doing. Now, the Cristofori piano was popular but not great. But what was easy to do was make improvements in it. And in particular, a German constructor named Gottfried Silbermann, who died in 1753, made pianos for Frederick the Great. And these pianos were played by, that piano that Frederick the Great had in particular was played by Johann Sebastian Bach, who didn't like it at first, but then grew to like it later on, as we shall see. A serious change occurred with Joseph Haydn, because his patron, as many of you will know, Prince Esterházy, in the Hungarian-Austrian border, had several of these pianos, which by this time were called forte pianos, not pianofortes. We'll talk about that in a bit. And these forte pianos, he composed numerous sonatas on this, and they sold very well. They became quite popular, and so he sold sheet music for people to learn how to play them, and then the piano became more and more popular, as I'm trying to say. In the 1760s, one of Bach's children, Johann Christian Bach, played a series of concerts in London, and that made a huge difference in the popularity of pianos. But the real change came about, not surprisingly, from one Wolfgang Amadeus Mozart. Mozart wrote, my goodness, he wrote 18 piano sonatas, 36 sonatas for violin and piano, and 27 piano concertos. And he played a lot of these when he was still a teenager in Vienna, and that made a huge impact and made the popularity of the piano really very intense. In 1774, Voltaire denigrated the piano and said nothing compared to the harpsichord. 26 years later, by the end of the century, pianists had more status than almost any other musician. So it really became very popular very quickly. And because it became popular, there were more and more pianos made, and that drove the costs down, so that by the end of the 18th century, pianos were sold in London for between 16 and 20 guineas. For those of us who don't know what a guinea is, it's a so-called the gentleman's pound, 21 shillings as opposed to 20 shillings for an ordinary person's pound. And 16 to 20 guineas in today's money is between, in Britain, 1,000 and 2,000 pounds, which is some astronomical South African sum, but a sum that even in those days was within the reach of the burgeoning middle class, who was growing due to the Industrial Revolution, which was taking place in that time. Now, the many more people started making pianos. Probably the most famous British maker was John Broadwood, who is a Scot, and he made pianos that had 5.5 octave span. Now, can you get the PC back? I want to play some music if I can. In 1818, Broadwood's son Thomas made a 6-octave piano, and he sent it as a gift to the composer Beethoven. And Beethoven wrote a piece of music for it, and I don't know whether it will come up or not. Oh, I can't even find it now. Oh, I know where to find it. Okay. Let's see. I don't know whether this will sound or not, but this is the music. You can hear that. Not bad for an 1818 piano. That's, of course, for some people will recognize the Clavier Sonata, and Beethoven composed that on the 6-octave Broadwood piano that had been given as a gift. I think a very valuable contribution that piano was. Now, Frederic Chopin did not give many public recitals, but when he did, he preferred to use a French piano made by an Austrian, Ignaz Pleyel, who had moved to Paris and was producing pianos. In 1825, Pleyel had 25 employees. A decade later, he had 250 employees, and 2 decades later, he was making 1,000 pianos a year. So a considerable growth. And Chopin, as I said, liked to play Pleyel pianos. I went to a concert years ago in London in which Andras Schiff played a combination of Beethoven and Chopin. And he had 2 pianos on stage. He played the Beethoven on a Steinway. He played the Chopin on a Pleyel. A bit of showing off, but nonetheless, it was really a very nice thing, I thought. In about a century, the piano had gone from a new invention to a dominant instrument. And it was particularly the growth of the Romantic music in piano, in music, and the enormous virtuosity of Franz Liszt and Anton Rubinstein that caused great growth in the use of the piano. Liszt is, by reputation at least, the greatest exponent, technical virtuoso of the piano in history. He was the first pianist to ever play entirely by memory. He invented the word recital. He was the first pianist to open the lid of the piano. And he was the first person to ever play an entire concert of only one instrument. He was also, like Paganini on the violin, enormously vain, and sold not only his technical ability, but also some amount of sex appeal as well. And for instance, he would often have on stage 2 pianos, opposite direction, so he could play half where the audience could see his right profile, and the other half where the audience could see his left profile. He was famous for such things. Now, the popularity of the piano led to not only a great burgeoning of piano production, but also to a huge introduction of sheet music for the piano. Huge Liszt made enormous numbers of transcriptions of symphonies and operas, and somebody once commented, try to imagine playing Wagner's Tannhäuser music on the harpsichord, which is not imaginable, at least for me. To give you an example, in 1843, Verdi published his opera, the first performance of which was I Lombardi, not one of his most popular operas, but okay. Within a decade, there were 245 different arrangements of the arias for that, different arrangements of the arias in sheet music in so-called easy style for the piano. The very first piano recital we know of was on the 6th of March in 1763. 70 years later, by 1850, virtually every house in Vienna had a piano inside it. And that is not entirely hyperbole, because we have a lot of statistical evidence for how many of these things we were. I really want to show you a slide. Oh, well, maybe tomorrow. Because what I wanted to show you is the piano led to huge amounts of intimacy in playing. And I have a wonderful picture. You know that Beethoven wrote a sonata called the Kreutzer Sonata. And in 1889, Tolstoy wrote a short story on the Kreutzer Sonata. And in 1910, a French artist, René Prinet, made the very famous picture on the Kreutzer Sonata, which maybe some of you have seen, in which the violinist reaches down and grabs this female accompanist and gives her a passionate kiss. And having heard the Kreutzer Sonata, I can sort of understand that, although I can't play either instrument to that kind of level. Okay. Now, in 1855, Henry Steinway made his first piano with an iron frame. He didn't invent it, but he made his first. This was a major development, and the use of an iron frame, because before this time, before the use of iron frames, the pegs were put into wood. And the forte piano, the piano which Beethoven and Mozart and Schubert all played, had all the pegs in wood, and you couldn't get not only the right enough tension on there, but there was also the problem of maintaining the tuning, because wood didn't have enough friction, and so things would slip a little bit, and so it wasn't always tuned as well as one would like. The first cast iron metal frame was patented in Boston in 1825 by a man named Alpheus Babcock, and he later went to work for Chickering Pianos, which was the biggest manufacturer of pianos in the United States, and they patented the first full cast iron plate for pianos in 1843. Both the English or the British producer, the Broadwood family, and the French manufacturer, the Erard brothers, both claimed the invention as early as 1820, but there's no patent or whatever. Now, in 1850, P.T. Barnum, a very famous name, invited Jenny Lind, the great Swedish soprano, to tour America, which she did, and gave some 90 concerts around the country. Barnum asked Chickering to make a special piano for her, which Chickering did, and it must have been one hell of an instrument, because Jenny Lind married the pianist. Now, Henry Steinway was born in Germany, and his name was Heinrich Steinweg. He was old enough to serve in the Prussian army in the fights against Napoleon, but in 1848, with the failed revolutions in Europe, he felt it necessary to emigrate, and he left and moved to the United States. He left the German piano manufacturing business to his son, and he started a manufacturing business in the US, and both Steinway businesses still exist to this day. He happened to land in Boston at the very time that the Chickering piano for Jenny Lind made its debut. And the story is told, I don't know how true it is, that he was at the first concert and was on stage looking inside the Chickering piano with its metal frame, and was so entranced that they couldn't begin the concert. They had to drag him off in order to start. Chickering was the leading producer of pianos in the middle of the 19th century, and they lasted as a brand until 1983 when they went out of business. But the name Chickering is still used on pianos. It's been bought by the Baldwin Piano Company. In any case, Steinway left Germany, and however, his pianos, as anybody knows, did more to create artistic tone quality and durability than any other maker. He, again, I can't show you a picture. He patented the system. If you look inside the piano, and look inside a grand piano, you will notice that the bass strings overlap the other strings, and that allows the nose of the piano to be a little bit narrower, and that was also invented and patented by Steinway. And Liszt and the other great artist of his time, Anton Rubinstein, are the ones who said that Steinway did more to create the artistic possibilities of the piano than any other maker. There are, of course, other very famous names in piano construction besides Broadwood and Steinway. There's Bösendorfer, there's Bechstein, and quite recently, certainly within my lifetime, there's a new Italian piano called the Fazioli, which has a very bright tone. And one of my favorite pianists, Angela Hewitt, the Canadian-British pianist, plays only the Fazioli, and it makes a lovely sound. So I can't show you anyway, when I showed you the picture of the Cristofori mechanism, I could show you the Erhardt variation on that, which is very similar, but it allows the key to be played much faster. Sorry. Pressing the key causes the lever, as we saw, to go up, and causes the hammer to hit the string. There are dampers, and if you keep your finger on the key, the dampers don't come down, and that allows the tone to be sustained. And it also, when the key moves down, if you've got your finger still on it, it doesn't move all the way down, it moves sort of halfway down, and that allows, again, faster repetition of notes. And that's one of the differences, if you will, between the grand piano and the upright piano, because in the upright piano, the hammer, when you keep your finger on it, moves back a bit. But in the grand piano, the hammer not only falls down because of normal action, but gravity helps as well. And in fact, you can generally play more rapidly on a grand piano than you can on an upright piano. On the piano also were developed pedals, and there are in really fancy pianos 3 pedals. The pedal to the left, if you look at that as you're sitting in the piano, the pedal to the left is called the soft pedal, because what it does is it shifts the hammers so that instead of hitting 3 strings, as there usually are, it only hits 2 strings. In early pianos, there were only 2 strings, not 3, so it moved it and only hit 1 string, and so that pedal is still called in Italian una corda, or 1 string. But it isn't, it hits 2 strings. But never mind. But since it hits fewer than 3 strings, it makes a softer sound. The pedal to the far right is called the sustaining pedal, and what it does, of course, is it keeps the dampers, all the dampers, from falling back down. And that's an important addition, because what it does is means that not only the string that you played is vibrating, but that string can then induce vibrations in or sympathetic vibrations in the other harmonic strings. And so it can cause the next octave up to vibrate, the fifth above that to vibrate, the octave above that to vibrate, the third above that to vibrate. And if I could show you the slides, I could show you the harmonic series again, which I can't. And then you could see, but that's what the sustaining pedal does. Okay, it keeps that. In some pianos, there's a middle pedal, and the middle pedal is a quasi-sustaining pedal. It keeps some of the dampers from coming down, but not all of them. But these pedals, which were originally operated by the knee, so that they were sideways and you pushed them with the knee, of course, are now operated by the feet. My favorite pianist in the whole world ever, Sviatoslav Richter, who has a great student who plays these days, Elizabeth Leonskaya, insisted you never, ever use the sustaining pedal. Do that. But he was the best pianist I have ever heard play. Now, another... And, he was the one playing the Hammer Clavier, by the way, which I couldn't resist. And that's a 1960-something recording, which is why the sound isn't so great, besides the fact that all I've got are these tinny little speakers. Another problem in the string comes from the hammers used. Remember that yesterday, the bow of the violin moves the string at a given point, wherever the violinist is pulling the bow or pushing the bow. And what that means is that that point where the bow is in contact is moving. And therefore, there cannot be a zero of that point. There cannot be a node, to use the official term, at that point. And that node means that a particular harmonic will not be there. The key on a piano, the string on a piano, is struck generally by about 1/7 of the way down, and that 1/7 means the seventh harmonic would normally be missing. By using felt, I can get, which is soft, you can get a little bit. On the other hand, you don't want too many high harmonics, because if you get too many high harmonics, you get a tinnier sound to the piano. And so using soft felt on the hammers damps out some of the higher, and what we hear fundamentally is the fundamental sound an octave higher and maybe a fifth above that. Excuse me, I need just to get my notes so I know what I'm doing here. Using a hard hammer or having a piano where the felt is old and hard gives you, as I said, a tinnier sound to the piano. And modern pianos actually have a much faster action. They have a better leverage, and the keys are faster, which also decreases the higher harmonics. The metal frame allows a greater tension, and it's also a very, very heavy frame, and that's made exceptionally heavy so that it does not vibrate at all, really, so it doesn't steal some of the energy from the strings. And I want to talk a little bit more about strings, because strings were originally cast iron for the higher strings, and they were brass for the lower strings. But by 1834, someone made cast steel strings, and that set off decades of competition for who could make the best piano wire. And that, of course, led to this phenomenally good piano wires that we have today, which is not in this device, which is all electric, but nonetheless. Now, piano wires, as I said, are very good. Those of you who may have read years and years